Phase deployment for SCC HA cluster setup. To this point, we have built successfully the Undercloud network in which SCC rides on top of. The SCC base kit has been copied to each SCC VM instance. Before we start running the bash script on both nodes, there is some additional prep work that needs to be completed. In order to have a favorable installation deployment experience, it is recommended you test reachability out to the internet for an online installation deployment. Each of the SCC Ubuntu instances have been upgraded to the latest kernel version. We have performed an apt-get upgrade on each of the SCC kernel instances of Ubuntu. This podcast was focused on a SCC Ubuntu kernel use case. However, there may be some enterprises out there that might perhaps want to deploy a kernel of either Rocky Linux, RHEL, or a flavor of CentOS. Each of these kernel versions are supported with SuperCloud Composer's HA cluster setup. Before you choose your storage service class offering, it is best we test whether VMs can ping the outside world. We will review the netplan script file and provide details how the VM connects to the bridges. Remember, each VM requires two VNIC connections, one that connects to the enterprise managed network, supporting internet outbound endpoints. The other VNIC connects to a SCC internal heartbeat network. For more discussion of the SCC heartbeat network, please consult the SCC installation guide for details. Also within the installation guide, we provide details of ports that need to be open in a standard whitelist of trusted endpoints. If online mode is not an option, especially in secure sites that restrict both inbound and outbound internet access, we offer customers an offline installer upon request. The offline installer can be applied to any SCC kernel flavor you wish to deploy as a VM instance. So let's conduct some tests before we jump into the final phase of our SCC HA cluster setup. Okay, I'm just going to review our configuration here within the lab. It's our customer evaluation lab that we provide access to customers to evaluate our products and our builds, sprint cycles or sprint builds. So we have 3 KVM hypervisors that are interconnected through a top of rack switch or enterprise switch. There is SCC KVM 1, SCC KVM 2, SCC KVM 3, and then we have each of those hypervisors hosting a appliance on their server, physical server. So we have for the KVM1 or SCC KVM hypervisor, we're in a subnet of 172.24.199.109/27 subnet. Its VM that's hosted on that hypervisor is 172.24.199.119/27. And you have a second hypervisor, SCC KVM2, 172.24.199.116/27 subnet. It's VM hosted on that hypervisor of 172.24.199.114/27. And the third hypervisor is at 172.24.199.115/27, and its appliance, which is hosted on the third KVM hypervisor, is 172.24.199.117/27. Our VIP assignment or virtual IP is 172.24.199.113. As I mentioned, these are spread across multiple racks and isolated in a bank of PDUs for redundancy capability and anti-infinity. Okay, so what we want to do now is we want to log in and really test reachability, take a look at some of the configurations that exist on the VM itself. We'll focus on the HA node 1, which is that appliance, which is hosted on hypervisor 1. So let's log into our dashboard. I've RDP'd into this system hypervisor. So let's log in as root. And the first thing I want to mention here is that we see the virtual machine manager. So this should not be foreign to you. You saw this virtual machine manager when we initially deployed our OS for our virtual machine from our repo area that was located in the Kevin root Kevin OS repo area, which was local to my operating system disk. So you can create a pool yourself or a storage pool for repos that exist for all of your OSs. I just happen to just use the system disk in my particular use case itself. But in an enterprise setup, you might want to take a look at deploying in a storage pool setup because there may be multiple VMs that are being hosted through this KVM hypervisor, right? We just have a very simple lab setup here to give you an idea how the cluster is set up. All right, so that is the virtual machine. So if we click on the open option here, the first thing I want to show you here is this little light bulb here. And when you make changes to any of these settings within this template here, you require the VM to be shut down, right? So you can't make changes while the VM is running. So you'll have to, shut it down and then make the appropriate changes and then start the VM back up with the new changes that take a place there. So reviewing the hardware configuration, when we deployed this, if you remember, we had virtual CPU allocation of 16. So we had 16 that are required. Where did we get this number from? We got it from the installation guide provided to you. And it talks about software requirements and hardware requirements in that installation guide. And then also the memory, right? The memory is 16384 MIB. So those are hard, fast numbers that you need to set in order for the VM to run efficiently. And you see here that we've got the SATA drive here. And remember here, we hosted this ISO in our local repo, which was local to our system disk. So that's how we were able to deploy a VM through using Virtual Machine Manager. And then we have two NICs, right? These two NICs are vNICs that are connected to our V ports on the bridges. So we have bridge 0, which is basically our IP address that we define on this VM. So it's a VM NIC, and we'll show you that in a minute when we log into the operating system. And then you also have the second NIC that's connected to BR1, which is really your subnet for your CNI or the SCC private network. So we talked about this previously in a video podcast or video clip here in this podcast about defining your own subnet, right? So the default is 10. And you say, well, gee, Kevin, what happens if I'm using a 10 subnet internally within my enterprise? No problem there. You can change whatever subnet you want, right? We give you the ability to change that subnet. You're not just restricted to the 10 subnet, right? But we do that by default. We choose 10 as a subnet. So if you choose to use a different subnet for your Kubernetes network, then you can do so. And we prompt you for that when you actually run the install script or the base kit when you start your HA cluster setup for SCC. So that is the NICs, the boot, the essentially the boot options, the virtual, the SATA SD-ROM that we have, and then memory and CPUs, right? And remember, to make changes anywhere in this configuration, you need to shut down the VM to make those changes. All right, so let's get into the actual console. So we've logged into the console, and then we did it ahead of time here. So simply you would just be prompted like any machine, whether it be a physical machine or a virtual machine, you're got to put in a username and password for credentials, right? So we're logged in here as root, and we're in the SCC cube directory where the actual tarball file exists. So we copied the tarball file up to this location, and then we'll run the tarball extraction utility to basically explode the tarball into various directories that are going to fall under this particular directory itself. So we'll do that in the next video clip where we get down to the mechanics of actually installing SCC itself for your HA cluster setup. So the next thing we want to do is let's verify here what Ubuntu version we're running, right? We can issue the command here. Here it is, lsb release -a. You can see here we're running Ubuntu 2204.5 LTS. It's the code name is Jammy. The release is 2204. So we did the upgrade. We did the app upgrade to the latest version of Ubuntu from the mirrors that existed out on the internet. So all 3 VMs are upgraded, or SCC kernel versions are upgraded, ready to run the install script. So let's do some, typical troubleshooting. So dig is a command. Some folks use dig, some folks use NSLOOKUP. I prefer to use dig. And let's just see if we can dig our Supermicro portal here, or our name server. And of course, it comes back with a response, right? So both forward and reverse lookup is possible here within our connection point. So if we wanted to ping www.supermicro.com to see if we get access out onto the internet, we can simply do so, right? And you can see here that it's doing the name lookup correctly. So let's see if we can ping www.cisco.com, okay, or maybe perhaps pinging www.google.com, right? So all of those are available, so we can get out onto the internet. So all is good. This is great. So far so good that we can hit those mirrors out there and be able to do those DNS entries and lookups to communicate with the mirrors and download appropriate containers and stuff like that as part of our installation package. So what else do we want to look at? Maybe perhaps we want to look at the file of how we configured our YAML file for our setup of interfaces with a VM. So we have EMP70. S0 is false, so it's going to get a DHCP address from our Kubernetes underlay. That's going to be part of this once we configure the base kit and the installation bash script to start the cluster setup. And we also have an IP address on our Bridge 0 interface, which is the management enterprise network. You can see here of 172.24.199.119. So that's our own IP address, and we've got a default route out to our default gateway of 199.126, and we have a name server address of 8.8.8. Incidentally, all of these hypervisors and also VMs connect into the same VLAN. So that's very important. So your enterprise management switch, in order for you to successfully communicate with the VIP, they all need to be in the same subnet, and they all need to be in the same VLAN. So if you've got hypervisors spread across multiple VLANs, not a good practice. That will not be the right setup, right? So they have to be all in the same VLAN, and let's see if we can ping any one of those HA nodes, right? So we can simply ping 172.24.199.119. So that's ourself, right? Let's see if we can ping ourself. We can. Okay. Let's see if we can ping the second HA node, right? Which is at .114. We can do so, great. And let's see if we can ping the third appliance, which is our third HA node, and we can. So that tells me that we are able to connect up to the upstream switch. Packets are being forwarded through the layer 2 switch in that VLAN, and also it's getting out the bridge port, right? The bridge 0 interface, right? If we weren't able to ping any of those HA nodes on our upstream switch or enterprise management switch, the bridge would not be working properly. So you say, well, gee, Kevin, what happens if I can't ping them? Well, it's possible you might have the wrong interface bound to the bridge 0 interface. Typical customers will swap the interchange the interfaces and confuse the bridge 0 and bridge 1 interface, right? So it's important you make sure you have the right interface bound to the bridge port, right? And because again, that's important moving forward of providing access to your HA node, right? So probably before you even start the VMs, you probably want to make sure that your hypervisors are able to ping each other, right? And that the bridges are configured correctly before setup, right? And do your pre-prep work. So that's all that we can look at for this particular video clip. The next series of video clips will focus on the SCC HA cluster setup. Thanks for joining today. You have a great day, and we'll see you next time.